If you're not familiar with the USB Type-C connector, it's a unique cable that solves all your connectivity by handling power and video on top of the USB data you're used to having. The USB Type-C allows me to replace the power, video, and USB cables I would normally use with my computer with this one cable. When evaluating the USB Type-C cable, you'll notice that both ends are identical and symmetrical, meaning there's no wrong way to plug it in. Let's take a look at how the pins are assigned to help you better understand how to build solutions for applications utilizing the USB Type-C connector. As mentioned earlier, there's a certain symmetry or mirroring of some of the pin assignments. Power and ground appear in a pattern that's the same if you flip it over and match them up, making it easy to insert the connector every time. The same trick is played with the USB 2.0 signals, only here we see that there are twice as many pins as really necessary to achieve the symmetry. For USB 2.0, you just wire the two together, D plus to D plus and D minus to D minus. This creates a short stub. Stubs are okay for low-speed signals, but they won't work for high-speed signals such as video. A different approach is taken for USB 3.1, which can achieve up to 10 megabits per second, and for video at above 5 megabits per second. Here the pins match up again in a simple pattern. If you insert the connector incorrectly, then it's like you've twisted the cord and the solution is to untwist it. So you need a MUX if you're doing just USB 3 or a more complicated cross-point switch if you're going to support video. The last pin required is the CC pin, which has many functions overlaid on it. The connector should not have any power when the connector is bare, and the CC pin tells the equipment if something has been connected or not. When connected, a voltage on the CC pin goes low to high by a resistor pulled up to 5 volts or to ground. The CC pin is also used to signal the capability of the item being connected to the equipment accepting the connection. It will know, for example, what protocols like USB 2 or 3 or video can be supported, as well as how much power it can provide or wants to consume. To accomplish this transaction, both low-speed and high-speed signaling is overlaid in the cable structure. Simple applications that require existing USB 2 and 3 capabilities or low power levels up to 15 watts will only need the low-speed signaling. Applications that utilize video, also called alternate mode in Type-C, or want to negotiate for more than a 15-watt connection will need the higher speed signaling. These applications are covered by a spec called USB Power Delivery. Texas Instruments has the devices to support the whole Type-C ecosystem. These devices assist in untwisting the wires of the muxes and crosspoints, supporting connect and disconnect, controlling power delivery, and lastly, they advertise the capabilities of the configuration channel pins, otherwise known as CC controllers. For more information, or to download data sheets, or to purchase devices in our USB Type-C ecosystem, visit us online at ti.com/USB. Thanks for watching.